that will be average 1.
Okay.
Then average 2, average 3, 200 points divided by 5. How many will you will have? 40 average you will have. This 40 average, when you plot 100% sure, you will get normality. This is called the central limit theorem. This is called central limit theorem because we require normality to apply all the statistical formulas. If normality is not happening, one way you can make it normal is instead of working with individual samples, you collect samples in subgroups, calculate subgroup average, and then use the subgroup average for all your calculation and everything. The visualization of the subgroup average or the histogram constructed using subgroup average will definitely follow normal distribution. Maybe I can share you this file. You can try. You will see central limit theorem working.
Yeah, that will be better.
If you have MINITAB, one minute. Yeah, I'll come to you. If you have MINITAB, go to file, go to open worksheet, go to sample data folder, look in sample data folder, and then you type here camshaft. This data will come, camshaft.mdw. Open. And now all of you will have this data file and you work on your own. Plot a histogram of this and then consider the numbers 5 each. And then you see whether your data is following normal or not. Yes. Okay. So then that will be clear. Now Ganesh Hegde, what is your question?
No. Just you told that you will share this Excel sheet. No, that's it. That's all.
Now it is available. See, plenty of data files are available for practice purpose. That is why we are suggesting you to use laptop and get familiar with the MINITAB. You can practice and then master all the tools. All right. So shall we go for the break?
No, RK sir, something.
Yeah, I will tell you once again. You wanted to know what is histogram? Yes or no?
Yes, sir. Yeah.
Right. I will just show my guys. Please permit me to share my screen.
Yes, sir.
Are you seeing the screen here?
Yes, sir. We are seeing. Yes.
Now see here, your how many people are there? 10 people are there. 10 black belt students are there. Now there are 5 brilliant students, 5 average students. Right. Now this brilliant students and average students are attributes. So I have charted this. This is 5 frequency. This is 5 frequency. Are you able to see this clear?
Yes, sir.
What is this chart? This is bar chart. Okay. Clear?
Yes, sir. Yes,
because
sir.
x-axis I am having attributes. Now I am going to find out the performance of you. 8 students have scored 60 marks and 2 students have scored 80 marks. Understood? Out of this, out of 10 students, 8 black belt students have scored 60 marks and 2 black belt students have scored 80 marks. So this I am plotting it here. Here what is x-axis? Is continuous data, ratio data. Therefore, this is called histogram and you have the gap between here at 70, nobody has scored. Therefore, there is a gap. Clear?
Okay. Yeah.
And then if it is like this, see, for example, one more like this, Control C, Control V. Now, and say this is a 40%, this is 40. I'll make it as 40 here, right? So 40 marks are scored by some 4 people and 5 people and 1 person scored as 80. Then this is almost close to normal distribution. From histograms, we can find out whether it is normal or not. And there is a gap lying in between because there is no mark there, no frequency. Clear?
Yes.
That's all. Thank you very much. This is nothing but histogram. X-axis differs. In bar chart, this is attribute. Here it is continuous data.
This residual versus a frequency, that kind of histogram.
Residual frequency means for how many items the variation is only within 2 marks. Like for example, for all the 10 students, I am giving the prediction and you will be scoring 60 marks and the other manager will be scoring 80 marks. I'm saying, right? Suppose I'm telling 4 people will score 60 marks and 6 people will score 80 marks.
Okay.
And 60 marks, what is the range residual? 2 marks plus or minus 2. Okay. Therefore, what is the frequency for residual 2? That's 6. Right? Because for 6 students, I have said 60 marks, where the residual is 2. I have scored 80 marks for 4 people. For the residue for that is say 2 marks. So 4 marks. That means 76 to 84. Then what is the frequency for residual 4? 4 people.
Okay.
Yes or no? So the residue is going to be this much for so many data, and this residue is going to be so much for so much of data. That is the frequency, right? And you want to minimize this. What is the residue, minimum residue, maximum frequency is the best model. Clear?
Minimum residual.
Minimum residue for maximum frequency.
Minimum residue.
That is the best result, right? That is the best prediction. Because almost for all the predictions, the residue will be this much. Maximum number of times, only low residue, low variation, low margin of error. Therefore, my aim is only to see, we all get all these answers, solutions, only by, that is why we say that we can't do this. Only computer can do this by iterations. All this can be done only by iterations, which human cannot do it. Thank you.
Yeah, thank you, sir. Yeah.